Hello, good evening. I hope you're having not just a good evening, but you're having a good week and that you have a good weekend too. So, welcome to this episode number 12 of the series of programming the Amiga in assembly. This time, let's make an Amiga game. So basically, we are writing an Amiga game. So please, as always, subscribe to our YouTube channel and like our videos. It's all I really ask. It motivates me. Please also follow us on Twitter, Instagram, and of course here Twitch. On Facebook, there is the Facebook page, which also I would encourage you to do a like on it. And also the two groups, Commodore Dev and Phaze101. Phaze101 is only related to Phaze101, so you just get all the news there. And Commodore Dev is anything related to Commodore. All the links are in the upper right hand corner of the screen, and if you need anything in relation to questions related to 68,000 assembly, please come on Discord and ask there. It's becoming a known fact now. I do have every week, there's always like one or two new ones that are asking, and I'm quite happy to be fair. So I am the more there are, the better. I mean, I also learn from you, believe it or not, because some mistakes I do them also, or sometimes you make me think about certain things. So yeah, please come on Discord and don't be afraid to ask. I'm more than happy to help. If you like what we do, then you can always support us on Patreon. As you can see, 11 is there, but 49, episode 49 is not there of the book. There is still episode 48. And same, there is coffee, okay? Whichever you like. I have no preference. As you can see, if you join, you unlock that amount of videos. Besides that, I remind you of the page. This is the page. You can also access it from the command line. If you type book page, it brings you a link to this page where there are all the links in relation to anything related to programming the 68,000. Also, if you type mega, you get access to the sources that I have shared so far. As you know, till episode 6 or 6.5, depends how you see it, they are on Mega, and there are also the videos are on YouTube, so one for each episode, and you can follow the episodes and you get the source. Till episode 11 now, I'm sharing them only with Patreon, but of course once I finish this series, they will be available, and I will be releasing them 1 week after the other. Just to make you aware, today I think we'll be very close to the close-up of the game. In terms of once I do the high score, etc. Not high score, the HUD, which I hope to do today. All what remains is like the intro screen, game over, and all that stuff, and then making it nicer. So it will be, I think we will wrap it up soon, this game, and then I will have to think of another game, because I do enjoy making these small, simple games. I will maybe add some other stuff in the new game that will come, but I try to keep it simple so that the aim of this is to people learn. Writing a game like what I'm doing on my other free time, which takes months to do, is not something that I like to do on a stream, because I think you'll get bored. I prefer to show you small, simple games, which we might use a technique 1 or 2, and you can use them in your games. Maybe you write a complex one, and it will be coming from these small, simple games that we learn here. So, yeah, I'm not thinking of doing a long series of games. I have put it this way. I have put a restriction on myself that no game will take more than 20 episodes. So yeah. So that means what we are saying, 20 episodes is 6 months roughly, which I think that's a lot. But doing an episode once a week, it's let's say also acceptable. However, I do not want to do games which take more than that. Like some that I see that are taking, I don't know, 60, 70 episodes. It's not for me. Those I prefer to do them on the side. Besides that, we have also, because I mentioned it, if you type Discord, !Discord, you should also get the link to Discord, because before I was not mentioning it, but it was always there. So please come and join our Discord. I'm more than happy to help. So before I start, I'd like to send my hellos to all the Phaze101 members and to all those that are in our Facebook groups, and also to all of you that come here and listen to me, and especially to those that support me. I cannot be more thankful than, to be honest, I'd like to be more thankful, but I do not know how yet. Maybe I will come up with some ideas of how to be more thankful. But I do appreciate your support. Also, I'd like to send my hellos to another group, the Retro Programmers Inside group, where, let's say, I mainly sit. So, let's show the game that we're trying to build up. I remind you, it's based on my friend's game that he wrote for the Commodore 64. Let me change the screen, yeah, and make it a bit bigger. Okay, so basically what we need to do is save the fellow from dying, while he's falling. As you can see, we have an energy bar and a depth bar, and the depth bar increases the longer we go down, and the energy bar goes down as soon as we hit something, as you can see. So this is basically our game. Right now we don't have these bars, we just have numbers, but we will transform them into numbers, and then if he stays a lot in the middle, he dies. So he needs to be on the side. That is basically the game that we are doing. So, last time I started this notes thing to show or to remember where I am or what I have missed. because I was really struggling to remember what we had agreed or what we have to do. So the first one, remember, we ended up with a bug which I did solve, and I took it offline also because we were after more than 2 hours, and normally after 2 hours I lose my voice anyway. So I'm going to show you, so it is number 1101, what I fixed, and they were really it was really simple to fix. So guys, I have diff. Okay, so what we had on the right side is what we had last week. On the left side is what I modified or what I fixed. The orange part is the comments that I edit. Okay, so don't be alarmed because you see too much orange. But there were 2 issues, okay, and I have indicated them with error, as you can see here. This one was a long and it should have been a word, and this one was a byte and it should have been a long word. That were the issues why the routine was not working. The rest is still the same except for the comments. You can see that, okay, I had made a copy of this, but it doesn't affect us. It could be removed basically. But the rest is the same, okay, and that's why the errors were just these 2. It's funny how these, once you get them wrong, how much trouble they can cause you. It's really funny. Anyway, those were the 2 issues that we had, this one and this one. And therefore, I'm going to show it to you working now as we left it with those things fixed. Actually, let's show you the actual code. Yeah, you can see I have word here and long. Okay, the rest is the same. And this time I added the comments for you so that you'll have the comments for those that are either on Patreon or in future when they get it and they want to check it out. They can have the understand it better. Of course, the source code is always, every video there's a source code for it, so you always get the source code related to that video. Okay, so let's run it. And remember, we have an Amiga 500 Kickstart 1.3. You will see that the score goes up. Let's see. I didn't, of course, then it looks. Let me run it again. See if the Let's see if the joystick is okay, because so we need to make that, and now it should be fine. Yeah, so now we should see the score going up, okay, every time it increments by 10. Oops. It's my fault. I hit the thing. Anyway, you get the gist. And of course it rebooted, because as I said, there's that issue that we need to take care of. Remember, in the middle it goes faster, and now I'm going to die. It reboots when it does that. So that's one thing that we need to sort out. So let's think a bit. What we need to fix or add is we have the collision now, and once we have a collision of 1, we go to game over, okay? And if we have a high score, we update the high score, and right now it exits, okay? Or it reboots, because that's what it does. So definitely we need to do something where we are updating the collision register, and where we were doing that, so that should be, if I remember correctly, is it player? Yes. So here is where we are detecting when we collide, and we just set this 1 right now, but that is not enough. We need to do something else, much more to this. So we need a routine that handles the collision, okay? And it has to somehow also make sure that CLX is cleared. Now we are already in a way clearing it, but it doesn't harm if we read it again and ignore what we read, okay? Just to be sure that we have cleared it, because it can have collisions in it, not related, okay? This is why I'm saying this, not related to what we want, okay? Let's say a sprite number 3 with sprite number 4. We are not interested in it, so we need to clear it. So definitely we need to create some sort of routine down here that handles collision. Handles collision. And as per name that I gave it, I used. So what we need to do here, when we collide, did I create the variable? Let's check variables. Did I create? Okay, yes, we did. So lives. Okay, so when we collide, we decrement the lives. Okay, right now we have 3, we decrement that. So sub.long, it is long, right? Yeah. Now this one, as you noticed, for score, oh, high score I have byte, that should be long. For score and high score, I have long, and I kept the same thing for live. So in theory, there could be, I don't know, the hex number FFFF 6534. Sorry, there could be FFFFFFF. That means like 4 million lives. So it could be a word, okay? I am not. I could make this W, okay, or byte, etc. But I'm just going to waste some time and some cycles like this. But for our game, it's so. Please don't bombard me just because I am using long for lives, okay? It's just to keep things simple. Because some people are crazy with optimization. I am not that type of person. I am not crazy with optimize. I only optimize when it's needed. In this game, definitely, we don't need to be concerned with optimization, and it is for learning purposes. So I do not want to complicate people's life. So we subtract 1 from lives. If we, so yeah, we subtracted 1, but if we, if we arrive to 0, then we need to do something. So first of all, okay, let's do that. And then if it's equal to 0, we need to do something. For now, I'm going to say x because I do not know. If we are not 0, we reset the collision variable. So no collision, we can continue, no? I'm noticing we need something here which I don't have yet. So when we hit, the issue is this. When we hit a sprite and hence we die, what happens to the sprites that are still on the screen? They continue to be there, or we reset them? Now, the original game that we are converting from, right now, they stay there and you just leave energy. However, I am thinking of not leaving them on the screen. And the reason being is that right now we have another defect in the game, which is when they respawn, sometimes they can come one on top of the other, which we will handle separately, and I don't think I will manage today, but it is there. Because of that, and that requires some thinking, I'm thinking that we should reset the sprites. And anyway, it's a good exercise, and it practically will be, from the top of my head, okay, a copy of another routine that we have. So it's just practice. Here we need Uh, so we need a routine to reset the sprite. So .s and reset sprites. However, for now I'm going to comment it out because we don't have it. And once we did this, we need to clear. So I do not need to do this, okay? We really do not need to do this. So basically what I'm going to do is take this, because we already read it, okay? But just in case something has happened and it might be set, etc. So when I'm exiting, if you notice, it is the last part. Let me find it, the game routine. You see, we are here, then it loops back. So it waits for the frame. Here it when it updates really. So is the last thing that I'm doing is, I could have done it here, okay? Move.w clx.0. I'm putting it there. Doesn't matter as long as I'm reading it where I know it's not going to affect anything. I'm making sure that if something happens elsewhere, I'm clearing it basically. That might have affected the register. It shouldn't, because it can only be read once in a frame and then afterwards it will have random data in it. But I just don't want it to start when we wait for our raster with some random data also in it. So it's just me being cautious. Most people don't do this, okay? And then I was going to type RET, but RTS in 68,000. Okay, so this is our routine. However, we're missing this part. If this is equal to 0, what do we do? For now, let's do. Let's come here. Exit. I think I'm trying to keep it simple in a way. And here we need to jump to this routine. Now, before I was using branch.s, branch to subroutine, and .s because it's close, it's one next to it. However, I'm going to use .w because they are all in the same segment, but if I decide to change the collision to another file, then I might have issues. So might as well do bsr.w. And we had this when I was splitting the files. So now I'm avoiding .s unless it is within the same routine. Okay, so like here, it's fine, but a separate routine I would use .w. As long as they are on the same segment. And anyway, branch to subroutine, you can only use it within the same section or segment or whatever you want to call it. I'm saying segment because of x86 now. But the right word is section. So I'm still not convinced I have the lives the lives being handled properly. But I'm going to leave it for now, and let's go. We have another routine which I think I started. There you go, and it says update score. So with the same thing we can do update. So this routine handles all the routines that are related to the update of the HUD. So we can do another one, okay, and call it update lives. But of course we need the lives routine. So this time let's do update lives. And did we in HUD? So if I go to the HUD, did we put a label for where we need to update the lives? So data. Okay, yes. So we have score digits, live digits, and high score digits. So we need live digits. And score digit is there, yeah. So I can practically, I think, yeah, copy this, put it here. There are some modifications to do to it. One of them is, where did I put the HUD? Data. Yeah, copy it, and we were in utils. Okay. So let's see, and this should be lives. And of course, update lives. If you notice the way I tend to code, okay, I'm sure many of you do the same thing, but I code in blocks, and blocks, even if it's a long one, I try to divide it into small ones where possible, not always, but where possible. I do not like to use a lot of branch to subroutines in the middle of another. So like this is fine, okay? We come here from the main loop and I have a series of branch to subroutines. But if I had to be here, I wouldn't be having other branch to subroutines. Okay, I prefer to be at this level, okay, from the game loop coming there and then doing the rest. However, it's not always possible also, so it depends. But I try to keep this little chunks small as much as possible. So this one, we only have 2 digits, so it's not 7 digits, the score is two digits, and that indicates the number of digits that we're going to display. I'm going to copy this up here, Now this one, so destination is live digit, and source is where we have our string, where we have our decimal string. Now this one we need, so we have 80. Oops. Okay, those that might not know this or know other things related to other processors, the 68,000 you can add 3 things together, not 2, like what I learned in the 6502 or what I'm learning on the x86. So basically you can add the register, another register, and another, say, offset. Okay, so this is our base, let's say that. Okay, then we have the 0, which is the place from where we have the digits where they start, and then we can offset them. But because we are our digits, so if I leave this 0, okay, or remove it, it will be just starting from 0 and thus 2. But the 2 will be at the beginning of the string. Remember, our string where we store decimal string, this one, is 9 digits long. And we know that the value of our score will be in the last 2 digits. So here, you tell it how much you want to skip from those digits. And here we say, I believe 8 should be correct. If not, we will see. And then here we need to tell it, where we are printing it, also we need to skip a number, because we have a number of spaces in front of the 0. If I will show you what I mean in a minute. So this one should be 6, I believe. I'm not sure if this should be 7 or 6, and this should be 8 or 7. But by trying that, I will find out, instead of complicating my life trying to do it in my head. I think that should be it, I think. Hold on. Yeah, 0 and they are there. For a moment I was thinking, where is source and how did I load source and destination, but it's this, no? They are there. So source and destination are there. We also have, here I have a problem actually. No, here I don't have a problem because it's core. But if it's lives, I do have a problem, because no, we did decrement it already, so no, I do not. Sorry, I'm just thinking out loud, sharing what I'm thinking with you. So yeah, this should be fine. Yeah. So let's see what's going to happen. What did I do for the player? Yeah, that I left it there without resetting the sprites for now. So, and here I left it. That should be along the high score. Okay, so let's run it. Bigger. So, can I stop it? No. Yeah, I can if I press F12. Okay, so what I was saying, okay, so this is how long our string is that we can display. I believe there is 8 of it. 1, 2, 3, 4, 5, 6, 7, 8. However, our number can be in memory, okay, in memory, not on the screen, can be 9, okay? So we needed to skip 1. So I said 8, the length for score. So we just need the left 8 digits, okay? Here I set 2, okay? So I just need the left 2 digits. But when I write, I also need to skip, you see, this is our starting position always when we start writing, because I did the print routine to only, I only edit, because in our case it doesn't make sense to add also the X. I only added the Y, so we only specify the Y where we want to write, and we always start with position 0, which happens to be here in this column, okay? So what I'm telling it is also to skip, okay, 6 or 7 digits. We'll see when we die how much is going to skip. So let's continue. Oops, 3 sets. Yeah, I need to fix that. Okay. So I said yeah, and then we reset it. So we came here. If life is not 0, exit, and we clear it and return. Yeah, but hold on. I need to clear this. If it's equal, we exit. We need to let's doesn't make sense of being there. So what I'm missing here, if it's equal to 0, we leave the collision, we leave it as 1, set to 1, so that we can exit our game, which actually 3 sets in our case. But if it's not equal to 0, we reset it to 0, so that we do not exit our game. So why it did exit? So first of all, the register is data. I'm going to move data here. So the register is what? What is data bar data I need? So collision, what is collision? There, it's a word. So boom. As always, this always gets me on the 68,000. So that should be 0. You see why I like to keep the registers, you know, here I kept them all long, because this thing so easy to make a mistake in specifying word or long word, etc. And today I saw it with Honey on the x86. He forgot to do that. You do not fully understand the flex for branching. So here there's a flag called 0 flag. Okay, if the value is 0, okay, then we branch. Okay, now if lives becomes 0, okay, then we branch. We skip this part. Okay, we skip this instruction. Okay, that's what it is. Imagine a location in memory, let's say that, just to so that you can maybe understand better. Imagine a location in memory that will have either 0 or a 1. When it is 0, then we branch according to the value of that. Okay, so we are checking, okay, that when lives, because we decremented it by 1, if we decrement it 3 times, it will become 0, no, because our lives is 3. So when it is 0, okay, because we are moving it here, okay, this is why last time I said there's a compare there. Okay, I'm going to leave it so that, for your sake, so that you understand. So the move instruction, if it's moving a value of 0 into a data register, it will set the 0 flag because it's a 0. But you can do a compare. Okay, it's the same thing as doing as a compare, is what we have in 0, a 0. Because the move instruction does that, sets the flag, we do not need to do this instruction, the compare. Okay, that's why. And compare is a subtraction. Okay, it's value is one register subtracting the other. Yes, the move sets the flag. You need, every time you need to do a check, okay, on something. Check what the move instruction does, or whatever the instruction does. Now, it does set the flag if it was at the 0. So on data registers, it does set the flag. But if it was an 80, it will not set the flag, okay? It doesn't work on address registers, it works on data registers. So you need to know that. I went into quite detail about this in the streams that I do on Saturday, on Sunday. I believe, I can't remember if it's chapter 8 or not, where I explain the differences of the flags and what they are and what instructions might affect them. There's quite a bit on it, because this is also where many fail, including myself. I still do it. I don't think that I don't fail on the flags. I do also make this mistake. So do I need to keep this compare here, or I can remove it? I'm going to comment out, and I'm going to say it's not needed. Okay. Needed because move sets the 0 flag anyway. Does that help? If you see it like that? I'm going to leave it, comment it out so that others see it and it helps others maybe, but yeah, it doesn't need to be there. And notice I did a compare long because I moved long. So this is also something that I fail quite a bit. On these, I really fail. Because you forget what you said. So let's try it again. I changed it to where now and see what's going to do. If I have something else. I mean, I don't mind if it starts resetting at the end when we lose 3 lives, but I want to see the number of lives decrementing. And what happens when that happens. Okay, so it's going to... Okay, it went... I saw what happened. It went from 3 to 1 immediately. So, why is that? That was quite so basically it happened because we did not reset the sprites. That's why we need to reset the sprites. So what happens is, you know, when you have a sprite and the other one is passing, so initially they collide, but then it continue moving, no? So what happens is, while it's moving, and it's moving every frame, okay, and to move 3 pixels, it's so fast that we will hardly see it. It will just do it immediately. So basically what's happened is it went from 3 to 1 in just not in 3 frames. Basically, I managed to catch it with the eye because I'm used to it, you know. So this is why we need the reset sprites. Yeah, good one. Okay, so we definitely need to build the reset sprites, else we will not be able to handle the lives. So, where shall we do this? I'm going to do it in utils because shall I do it in enemies? Let's do it in enemies. I think it's better if it's in enemies. Because to be fair, I would like to separate the routines of the HUD to a different file. The routines that are like the hex conversion, okay, which we are in utils, sorry, like this one. This is a utility, no? But these are all HUD related, so I should have a separate file for them, which we will do. So, however, the enemies, we are resetting the sprites, so it should be here to make it easy. And also, we can practically copy this one, I think, because it will have lots of parts from this routine. So in a way, it's a good thing that I came here. Let's see if this one, no, definitely not from this one, but from this one. So, I'm going to leave those because it doesn't, it's good info. So here, I'm going to say reset sprites. Now, we need to remember the structure that we had, okay? And we have a structure which is defined here, okay? It's a total of 6, which is this, okay? The first one is defined, it's a byte, okay? And it says if it's FF, it's active. If it's 0, it's inactive, this sprite. The second one is which number of the sprite we have, okay? So that we know which data we need to copy. The this one, the second and fourth, and the reason why it is fourth because these are per how big they are. This should be W, I believe. 1, 2, 3, 4, 5, 6. Okay, I'm going to leave it as it is, but I think it should be W, that one. So I was saying the Y, okay, is weird because our screen, although we have from 0 to 255, the screen is bigger now, where we display the sprite. So this is why it is a word. The X is a byte. It does fit, but we can also have it as a word. For now, I'm just going to leave it as is. And then we have one empty. And the reason why I still use the one empty, if you notice, I defined 6 because on the 68,000, remember, it needs even addresses. So I cannot tell it to point to a structure that starts at an odd address. If I leave it as 5, we get a guru basically. And we've seen this. I mean, there was the bug that I took advantage of. We had this bug and I explained how the debugger works. So this is why we need to keep it even. But as I said, this makes sense to be a word. I'm just keeping it byte, but because to be fair, we are only using these 3 positions, so we are not getting out of 256. But if we had a different game, this will be different. And this type of structure, you will use it quite a bit. Having a sprite to know if it's active or not, what number you are on, X and Y of the sprite. This is something that you will need. And then you'll have another byte or 2 to say the capabilities of the sprite, or in which mode, or in what animation it is, etc. So it depends. In our case, we don't have animation of the sprites, so I do not need it. And they don't have special powers, let's say shooting or something like that. So, but if we did, it will be in the structure of the sprite. I mean, this is us, like creating an object, like in modern languages of today, where you have, let's say, C++, where you have classes or objects, C#, let's put it this way, you define these things. In assembly, you create a structure. You can use, there are special assembler directives for creating a structure in assembly, but to be fair, I mean, the OS makes use of them, but to be fair, I tend to use this method of defining them, define constant byte or word, and so far it was never a big issue. So yeah. Okay, so let's think about what this routine is going to do, or what we need it to do. The first part is where we get the enemy table screen. So basically this tells us, let's find it. It's here. Okay, it's this structure. We have, for each sprite that we have on the screen, we have this table with this information. Okay, so we need to get the beginning of it, and that's what we did. Okay, that's what we are doing. And D4 is going to hold the the number where we can have 6 maximum, so we're going to loop through these 6. Okay, now the first thing is we read the first structure, the first byte of this structure, okay, and we check, is this sprite active, yes or no? Okay, if it's not active, okay, we skip it. We go down here and we add 6, so the length of the structure, and we add 1 to d4 because we know that the maximum enemies on the screen is 6. So we go and read the next one. Let's say the first one is not being used, the second one is active. Okay, if it's active, what do? This needs to be done for, I have done this for safety. Okay, when I was explaining this to you guys, I said let's clear the registers before we start using them in our loop. And the reason why I did it is like this. Okay, this is something that I do often, even if I don't need to, I still do it, because if you start to debug the routine, okay, and let's say you have an issue somewhere like this in your mind, you know you started with a register that is clean. Okay, this is why it is there. I'm pretty sure that if I had to analyze the routine and optimize it, I will take these off. Okay, so I'm wasting a lot in this game when it comes to cycles and memory in a way, but it's so simple. I forgot to show you how much is it taking of memory that really it doesn't make sense. But I will show you later on. And if I forget, just remind me. Just do hey listen, okay? And I will show you how much it's taking. So we are clearing the registers, okay? Then what we are doing, and this is where we might need to start changing stuff. So what we need to do is start setting the sprite. So if it's active, we need to make it inactive. So we need to put it 0, okay, in 80, because 80 points to our structure, you know. Remember, 80 holds the entry point for the table. We incremented the table, so we are in, let's say, in number 1 of our structure, we incremented the table, okay, by 6. So, but we still need to set it to 0. So now here, I think I better clean this up, this part. I think I better clear it up because it might confuse us. And actually, because we do have, look, you see what we have down below. When it exits the screen, we actually deactivate it. So we might as well deactivate, use the same part. Okay? So the score, of course, we don't edit, so that goes. Okay? What remains is what we need. Okay? We set it to 0. Okay? We set the Y to the bottom of the screen, and this is FF is the bottom of the screen, plus 16 the height of the sprite, and 1 to be out of the screen. Okay, so it's not, and notice it's 280. So 2, if we add 2, we are setting the enemy Y. Okay, enemy.y. That's why I used the numbers are how they're offset. Okay, not 1, 2, 3, 4, 5, you know, that's why they are like that. So we set this to the bottom of the screen, the Y, and this one, the 0, we also excuse me, store it in the 0, and I tell you why. Because one is this structure that we have in memory, and one is the Amiga structure that we need to set. Okay, so there are two things that we need to update: our structure that has the information, and the Amiga structure, which is if I go to C data, yeah, it is. You see, we need to update the Y position and the H position. In this case, we're going to update both here. So that's why the value is also stored in the 0. So later on, we're going to do something with the 0. Okay. So we set that to 0. And we set the Y. Now we need the same thing. We need to get the structure where it is, okay, based on the sprite number. So we read this number, okay, and we need to get the address that I showed you here in the where is C sprite. We get the address of the sprite. So if it's sprite number 3, we're going to get this address, okay? And we are going to write in this structure, sprite structure of, so this is one sprite, okay? And remember, the Amiga has 4 bytes at the beginning that indicate something to it, so it's a structure. Then we have where the data is, okay, this part, and then the end of the structure. So the OS, not just the hardware, even the OS is full of data structures, okay? So yeah, today I actually, while we are at it, while listening to Dr. Hani today, he was mentioning in the 8086 how the system calls are done or can be done. And the x86, they all rely on this tech. The Amiga doesn't rely much on this tech. The Amiga relies on structures. So for each, let's say you want to open a window, you define a structure for that. And for many, if it's a task, also you define a structure and things like that. I'm not saying it doesn't use this tech at all, but it's a different way of doing things. And even the system calls, if it's a minus, the system call starts with a minus, then it means it's a jump table. If it's with a plus, it means we're going through a structure. So the entry point for the library is somewhere in the middle, which is different concept, but yeah. Anyway, I believe Linux uses the same method, but the Amiga is very different. So this part we need. This part we need. We are updating, okay, the X value of this sprite. This one we need because our sprite is how high is our sprite. And then we call our routine. Okay. So I had forgotten what I've done here, but we are calling the move sprite routine. So based on our X, Y, etc., we are now setting the structure where it goes. Okay. Then once we set the Amiga structure, data structure, we set our structure. We update, we go to the next structure. So we have set our structure. This part is setting our structure, okay, setting this structure. this part is updating the Amiga structure, the ones that I was saying here, is updating this structure. And then, okay, we just increment 6, 1 to our D4, make sure that we have not reached the maximum number of sprites that we have, and we loop back. So basically this routine is a copy of this one without this part. That's what really it is. That's good. We saved time. Unless I'm missing something, this should be right. Actually, I am missing something. Of course, if we move the sprite to the bottom, okay, and everything is at 0, we need to call respawn. I tell you why. So here we have update respawn, okay, and when they expire, when they exit, okay, we generate ones, but here we are we generate another one, but here we are terminating everything. So we have a routine which is, where is it? Init respawn, okay, we need to reinitialize it. So this one is the only addition that we need to do here. So change to subroutine dot w and init respawn. Yeah, that's what we called it. Okay. I think I think we have, for example, okay, before I was saying that, so we went into the collision register, and so what caused reset sprites? Okay, reset sprite is called, where do we have collision? No, player. So before I was saying, okay, that we have, you see, this for me, okay, is, we're going another level down from this one. So basically we check for collision and check for collision, which is this one, called this one. But now I'm going another level down. This is really not how I really like it. I prefer to have a collection, okay? First check collision, then call handle collision, and then call reset sprites. But for now, I'm just going to leave it there. But it would be nice if we do something like what we are doing with the HUD, because as the nesting of the routines will be when you go too much deep, you will start losing track of how deep you went, and like that it's easier to keep. If you go from the main loop one down and maybe another one is fine, but after 3 it starts to get you start to get lost. Let's put it this way. Some people do these things. I tend to avoid it, even if it's going to cost me more cycles, unless I am desperate for time. I will try not not to do it. So yeah, so now we can call this one. Oops, what did I do? We can call this. I'm pretty sure after this stream I'm going to fix this because it's already annoying me as it is. It's from here we jump here, so that's 1 level, 2 levels, 3 levels. Not what I like. And once we do the intro, okay, so we have an intro screen, an introductory screen, and then we jump into our game loop, and then game over, etc. Those are also sub levels. Well, not the intro, but you know, it's adding more. I don't like nesting too much, so yeah. Of course, everyone has got his way of doing things, okay? So I'm not saying that my method is right. It's just the way I like to do things. So first, let's assemble it. Let's see if I get any issues. But while it gave us an error, look how much our code is. This game is only not even 5K, okay? That's how much the game code is, and in that game code we have also our data, okay? The variables and all that stuff, okay? These are the sprites, the copper, how much the copper is taking, and the GFX. So this is the screen, okay? Loading the screen. But guys, honestly, it's a 5K game so far, and not even 5K. Because, as I told you last time, these, okay, stop complaining. These, okay, should not be in game code, okay, in the same section. So, to be fair, it's a very small game, very small game, but it does the job. You see, another one, branch to subroutine.s, no, .w. I forgot what was the error. Oh, that was the error actually. So let's see what's going to happen. Hold on. I forgot to switch to this mode. Okay. So let's see. We should see the score going up. Yeah. And now let's see. Oops. We went to 2. You see? And we're going to go to 1. Yeah. And now when they go to 0, we should reset. Boom. Okay. So yeah, it's getting there. So we have the lives working, we have the score working, we have the reset of the sprites. So now we need I'm just thinking what to do next. Let me see what I had written. So we did this. This I cannot really do right now. Collision, we lose a life, yes. Score update, yes. So wow, I did this more quicker than I thought. Wow. Wow. Yeah, because we had 2 routines, to be fair, that were there already. Wow. Okay. And we are quite good on time. This I'm really going to leave. I'm going to move it actually, because in half an hour we will not fix it and it needs some thinking. Okay, so this is from, and this should be, this mistake from me, that's 11, but this should be 12. And this should be 1. So this should be 12. We don't have enough time for this, so I'm just going to skip it for now. Anyway, but I really didn't expect to even be where I am. Sometimes assembly surprises me. Okay, so this is actually, because I had doubts on this, the handle collision, making it 0, etc. This is actually working as it should. Okay, so how shall we deal with another screen? Because once we die, we should jump and print something like game over, no? So how are we handling the screen? I just need to remember now things. So we have our copy list for our main screen, but the data for it. Okay. So we can either create another screen, which I wouldn't do. What I will do, so we have data, let me check that. And this is going to be here. So every time we can point it to it. So, okay, let's have another screen. I'm going to call it game over screen. And normally I do this. And here we, for now, okay, it's not going to be always like this, but for now I'm going to do this. Because there we had, I will need to change, hold on, I said I will use the same screen, but that means define constant block dot Sprite, and let's make it 320 times 256 but this division by 8 to make it bytes, and then we need it times 4-bit planes for now. Yeah. But I can do define storage. and then I fill it with zeros. I think I'm missing something here. So I have the habit of, when it comes to these things, I have the start of it, where it is, and the end. It's easy to calculate the size by doing game over screen underscore end minus, and I let the assembler calculate this for me instead of me wondering how much it's taking. It's just a habit. I need to check something on the manual of Phaze101, because I might be wrong in the way I define that. Let me go on it and I'll show you what I mean. So visual copy. So Phaze101. Okay, so let me show you what I'm talking about. Can you see the screen? I mean, you can see the screen. Can you read it? That's what I mean. Yeah, maybe like that. Okay, so we need Motorola syntax 68K, and we need the define constants, because define constants here. This is block, but I want define constant block. Shall I use this expression comma fill? And I use define constant block dot byte, right? Or not? I forgot what I did now. Define constant. Now this is not really the best way of doing it. All I want is a screen where I write game over, okay? That's what I'm trying to achieve here. However, the default screen, so what I'm always trying to do is, because to write the text game over, I do not need even 16 colors, so I can do this, okay? But, and like that I have a screen block of 1-bit plain where I can write game over, but the issue that I have is that in our copper, okay, in our copper, okay, we are defining a screen that is for bit planes, okay? It's this. Hence, and we do that by writing, where is register 100 there. So what we can do is change this, but so these 3 bits, okay, define how many bit planes we have, okay, and right now we have 4. 1, 2, 4, okay. Now I need 1, so I need to change the value that I have here to, I'm just going to copy it so it's not too affected, okay, and so that you can see it. So I need this to be this 1 and this 0. And this is all explained in the comments up here. So you can see these 3 bits define the number of bit planes that we have. And notice I like to use binary so that I can easily compare. First of all, on top I write the bit position, okay, and like that I can easily compare. I mean, this table I wouldn't normally write so many comments, okay, but this is, I did it for you guys, so you don't need to go and search what each one of them means. I mean, and this one, register 100, you will practically learn it by heart because you'll use it so many times. Bit 9, you always need to have it on, okay, this one, as you will not be compatible with the other Amigas, but the rest is off and you have these on. And then if you need hold and modify, you enable this, you have playfield, you enable this, etc, etc. High resolution, you enable this, and it continues. Interlace, you have this. You learn these by heart eventually. So the problem that I have is that I need to come here and write to it. Now, in theory, I should use another copper register and change that by having another copper list. But that is what I'm doing right now on a Saturday. Actually, I think I do it this weekend, where I explain when you jump from one copper list to another. And because I said everything will be done till chapter 7, I am trying not to use that. So I'm just going to give this, okay, this I can delete it now. So I'm just going to give it a name. This one, I forgot to register 100, I forgot. PPL-con 0, if I remember correctly. That's the name of it. I will check it. So you should all know how to use this, okay? The Amiga hardware registers, and we set 100. So it's this one, PPL-con 0. There you go, I was right. Remember, the copper adds the DFF, okay? So although we do not see it, we don't specify it in the register, in the data, it is adding that value. So 100 and the value that we want to put into the 100. So it's a move instruction in a way. And in front of the 100 there is DFF, okay? Remember how it works. So we need to write that value in in the high byte of it. Okay, so we can write in 100 basically, and 101 we leave it as it is. I'm just seeing if there's something else that will affect us, because these we will zero them. Okay, we will zero all these. So we need a routine to initialize the bitplane pointers and make them to 0, except for the one that we need. And then we need to set this. Sorry, not this, because that's the collision register. Okay. So let's write the routine that initializes these to 0. Okay, let's handle that. That should be easy. And why it is easy is because we have already a routine that initializes them. So we need to just copy that. So in utils, I believe, yeah, we have, there it is, init bitplanes. Okay, now this I'm going to put a game bitplanes, init game bitplanes. I'm going to leave it with the same name, but for now, init game bitplanes, and we're going to do this. So game over screen now. We might not finish this today, okay, but we're going to start it. So this init game overs bitplanes, and init game over. It's too long. API. So instead of pointing it, so where is it? So we point to our game over screen, and we get the bitplane pointers. Okay, so now we only have one bitplane, but we need, to be fair, we don't even need to initialize them. We only need to change the first bitplane, because the other ones we're going to disable them. So okay, actually this is going to be more simple than I thought. What we need is this. It's just that. That we are going to store the low address of our bitplane into the first bitplane. So for A1, so this is 0, 1, okay, 2, 3, and 4. So we're going to, starting from here, we're going to write a word here. So that's why for A1, because A1 points to the game bitplane pointers. where we have our pointers. It's misleading. Now it is misleading, no, because the same pointers, we are using them not just for the game, we are using also for the screen, for the game over. So it makes sense to drop the game and say bitplane pointers. But anyway, that means going through all the source code and correcting it. So for now, leave it like that. But what's important is that we are passing the game over screen. If I was not live and I'm doing this for myself, and I would be going and correcting those names because I'm picky on these things. But in this case, we will continue as it is. Also, when you have a big game, the namings, you need to get them right, as you'll start confusing yourself. But in our case, it's not a big deal. So we moved the lower into here, okay, and then because it's a 0 here, I do not need to specify that. It is there to make it obvious for you. The high word, I write it here. Of course, this is the register id0, okay, and remember, in front of id0 there is TFF. So once we did this, I'm just going to delete these now. We need to set this one, okay, splitcon 0. So now this one I will have to be very careful. Set game over screen. Why I'm saying I need to be very careful? Because I need to make sure that it happens when nothing is being drawn on the screen, because else we will see lots of garbage. So I need to think where to put this. It should be done in the vertical blank. While we are waiting on the screen, let's do it first. Let's try the routine and then we will think where to put it. Okay, because else I will be wasting time, and we are close to 2 hours anyway. So we have LEA. I was surprised to see that the 68 x86 has the instruction LEA. I'm quite surprised about that, although the use is not the same, I think, from what I saw. So it does point to an address, but not as the 68,000 does, because of the segmentations. It's a bit different. Anyway, out of subject now. LEA, and what did we name it? Game over screen. No, not that. And the copper. Here. bpl 0. Now I'm using bpl 0, okay? That's the name of the register. So if I was using the Amiga hardware include files, that name will clash, okay, with the OS include files, and because the OS has also the hardware registers. But in our case, I'm not using the Amiga hardware include files, so it's okay to use that. Comma 80. And no, I cannot use PC. And then move .byte. Yeah. And yeah, move .byte. Immediate %. And we need 0, 0, 0, 1. And then the rest is 0, 1, 2, 3, 4. Hold on, no. 9, we needed 1. It has to be this one, right? Because this one is 8, 9, 10, 11, 12, 13, 14, 15. Next. Move.byte, comma, and in A0, and the address pointed to by A0. Is all that we need. Now, what we need is when to write this, because you cannot go and change it just like that, because if I change that, you will see garbage for a moment on the screen. So we need to where is our game routine? So we have this, okay, and weight raster, which is also in the utilities. Weights, where is it? There you go. Weights for line 1 to C. Okay, so it is somewhere at the bottom of the screen, okay, which is quite good, okay. Hence, if we change exactly after, when it's the first thing that we do, we should be fine. The only thing is we are not, once we go into the game over, we are not anymore into this loop. No? Hence, we jump. So we should jump, we should call that somewhere here where we have the game over. So what we can do is call weight raster again. So this is the game over part, okay? The update high score, for now we leave it. And then we where did I write? Here. Yeah. We need to call init bit plane, init, so branch to subroutine word, and we need to call init game over PL, and we need to call set game over screen. Then we need to write something on the screen. So we definitely need, okay, this routine. So do you see that all the blocks that I'm using now are already defined in the game? That's why it's a simple game. The blocks are repeatedly used. But the print info, okay, points, I believe, points to the HUD. Let's check what it does. So we might need to modify that now. Yeah, as you can see, we wrote this that it points to the HUD. While what we should do, we should modify this that we pass it where we want to write. But if we do that, we will have other problems, because this was written specifically to write in the HUD. But we can, I'm going to use it temporarily, okay? Because the screen will be cleared and we are going to write to the HUD. So whatever we write, we should see some, let's say, garbage. But at least we wrote something, okay? And then we need to wait for mouse again as so, given that it's going to work, okay? So I'm just going to call this mouse1 because I don't know if I have any issues. It's okay to try. The worst that can happen is we see a guru. So what shall we write? What it will write to the screen? It will write, if we call print info, it's going to write what is in the HUD, but with a screen cleared, which for now I can accept it instead of game over, and then we modify the thing. Okay, let's leave it like that. Let's see what's going to happen. But we need to save all the files that I modified. They could have made this bar a bit bigger. I really don't like it. Okay, so let's try to assemble it. Yeah, okay. And let's see what happens when we start losing lives. Now, oh, we are 5064 bytes. The code, we we are nearly 1, so we came live 2, okay? I'm not going to play it, I'm just going to live 1. And now Oops, I told you we're going to see garbage, and I meant it. We will need to fix this. This is, I think I know what it is, but it needs to wait to the next stream. But okay, at least we have. And if I click the mouse button, okay, if I click the mouse button, I think it will reset now. Yeah, boom, and it went out. Okay, so somehow, okay, we did, although we waited for the screen and we did change the bit planes, we still got garbage. And the garbage is we have memory that although we initialized it with 0, we did not call it, we did not just an infrastructure test, comma 0. Where is the structure test, comma 0? So when we see that garbage, we are here, no? Now the problem is, there are two problems, okay? One is this, which tries to write something, but it was made to write into the HUD, and the HUD, in a way, will be disposed of it. Let's put it this way. I'm comparing to Nazim struct. It is, let me show you. I do not know the Nazim struct, okay? So you're telling me, but I'm going to show you what is for the 68,000, okay? So, I mean, this web, I have a web browser, okay? I'm going to be honest. I have a web browser with all the links, as you can see it on top, and these links never change. When I'm coding, I'm always opening this browser, and in fact, what do I call it? You see, it has a profile of Amiga, okay? And I have several profiles, and this one, when I'm coding, I switch to this profile. And basically, so let me find, here it is. So struct is called RS. Let me look it up, because I think it's RS could be, yes, could be RS. It's going to, it's I think it's RST, the structure thing. I think we are quicker if we scroll it. So here's macros. That's the repeat. Here it is. These are used to create structures. Yeah, because I know they start with R, but I do not use them. I believe Nazim has got something like this. I do believe it has something like that. I can, let me see if I find the manual. I can show you an example of a struct build up with if I need to find another manual of the as in one, basically, but I should be able to do that. Which do I have as in one here? No, but I will show you, because I thought about when you were talking today. I did think about this. Assemblers, there you go. I was wondering where it is for a moment. And I'm going to load DevPack and Phaze101 manuals so that I can show you an example. Let me find the page first, and then I will make it bigger. So these are commands, not the assembler directives. Here are the assembler directives. So let's find, there you are, and you see how he defines. Oh, I need to make it big. And maybe make it bigger. That is too big. Let's do 400%. I need to be on the other side. Yeah. So he's going to define a structure, and you can see this is how he defines the structure. Does that I mean, there's more to it. I'm just showing you just to give you, but basically what he does is gives a number. So like what I was doing, I had 0, 1, 2, and then 4, etc. He is giving a number, and you can see it here, okay, to each one of these, to the structure part. I'm pretty sure the x86 has it. I mean, this is quite a known thing for the assembler. Let's see if there's so the RS directive is one of them, but there is more. I'm just trying to find. This is to reset it, so it starts from 0. This is to have it relative, and then macro start. So it has these three in Phaze101. In DevPack, let me find it. It will be very similar in DevPack, but it's good to know these things about the assembler and that it can do certain things. These are the parameters for it. It must be here now. I'm close to it. Look here. This manual goes in more detail about it. Let me make it bigger. So you can see he's using it and giving the and you can see you can also use it for flags. The OS, the Amiga OS, is full of these. Anyway, just to to give you an idea. I mean, this I thought the ASM1 defines it better, but actually defpeg defines, there's more to it. So yeah, that's basically it. It's handy. Let's put it this way. If you look, so I'm just going to tell you from the top of my head, okay? Because I might be wrong, but when I was, and it's not NASM but MESM, so the Microsoft version of NASM, there were quite a number of examples that used this method. So if you check the examples of MESM, I'm pretty sure that there should be examples of NASM that has it. Because at my time I was using not NASM but MESM, of course. I had it at work, I remember. So I will stop here and we will continue next week. I'm quite happy with the progress. I'm going to write some notes. So in 13, okay, 1, I want to have the game over screen, and because it will be practically a copy, I want also to have the intro screen, and this should be easy. Also add music. That's what I'd like to have in 13. And hopefully I would have thought about fixing the respawn, because that needs some thinking. So guys, I hope you have a nice week. For those that a nice weekend, and for those that are going to follow me tomorrow or Sunday, see you tomorrow or Sunday. As next week, today week, we continue with the game. Okay, thank you very much and goodbye. Bye bye.